All right, have you guys used sunscreens before? Some of you do. Go to the beach, spring break, yay! So we use sunscreen and sunblocks. Depends on what they call it, all right? But yeah, here's how it works. Let's take a look at some of them, all right? Let's talk about the sun. What makes you burn, right? What makes you have a sunburn? Well, there are multiple types, but there are two main types of UV. The UV that causes the burning feeling right there, right? Burning of your skin. There are a higher energy UV, we call UVB, right? And the lower energy UVA. Right? As you see, the lambda, the wavelength is different. The UVB, the higher energy one, that's caused you sunburn, aging of the skin, eye damage if you look at the sun for a long period of time, and skin cancer for over time. Okay, the UVA actually give you the tan. That's what we want if you want to get tan. Okay, here's what we do. Well, if you just want to get tan and don't want any side effect from the sun, from all the UV, right? So what you have to do? Well, you have to block UVB. All right, keep the UVA but block UVB. All right, when you sit like sand or sunbathing or stand under the sun, well, you get both UVA and UVB. How do we block UVB though? Well, that's what a sunscreen or sunblock for. Okay, so you're gonna apply all this cream, like lotion, look like a lotion or cream texture material on your skin, right? This sunscreen will block only UVB, leave just UVA to on your skin to come to contact with your skin, and that's how you get a sun kiss. Hey, get tanning. Okay, and now here's the chemistry behind it. The material is actually, many of them, not all of them, but many of them are an ester, right? Look like that. When an ester receives the both UV, this is what happened to it. Of course, it gains energy. The electrons start move on to the excited state, come back down, right, and release heat or energy back to the environment. Okay, and here's what happened. Well, this guy has to, when become activated, right? So receive the energy from the sun, and this compound become activated. It has to release energy somehow, right? Here's how it works. Let's take a look. Chemistry behind it. The double bond is easiest. Pi bond in here, probably the easiest to break. So it break in, and this is from light, so you get the radical, right? It's all light chemistry. Okay, so we break, look like a diradical like that, and this radical, this what happened when become a diradical. Now you have a single bond now, right? See, since CC single bond can rotate, it can rotate. That's how it release energy, and then reform the double bond. So basically, this compound just go back and forth between cis and trans isomer. These are in equilibrium, right? This guy can absorb energy and go back to the trans, which is more stable, confirm the isomers. Okay, hopping back between cis and trans isomer is how this compound release energy, and which is does nothing happen to us, because they just receive the energy for us. Okay, now there are multiple, many types of sunscreen. Where or what? Which one should you buy? Well, it depends on what you want to do with it, but at least you're probably familiar with the word SPF, which means sun protection factor. All right, SPF 30 means only 1/30th radiation will reach your skin, which means that the higher, the better blocking ability it has. All right, so 60, so only 1/60th of radiation from the sun reach your skin. We have SPF 50, 30, 30, and 50. Okay, so the higher SPF value is more expensive it is. So this depends on how much money you have and how much you want to get sunburned. So, right, money in your pocket. These are the new one. The old one though, the active ingredient are zinc oxide or titanium 4 oxide, right? And like this is the old one. So it what's it called? It leaves like a white patch on your body, look like that. So this look kind of weird, but the new one, they don't do this anymore, right? So we use all the organic compound. Okay, fun to know. All right, let's move on to one more, amides.